Today's stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I am Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is a follow-up to this thing. It's an experiment. And in case you have not been following my streams lately, what we've been up to is a library that will help you develop relatively easier to use and hopefully better looking JS effects. And one of the main things of this library is that it is going to help you show what's going on in the audio effects. So one important component is this, the Waveform Visualizer. It's going to show you in real time what the audio, what is happening to the audio, which is useful for things like compressors. And it may help teach what compression even is and how it works and what it's doing to the audio, which I think is a great thing. So we are drawing this across the screen, and there is a whole backstory to how we're doing that and the problems in that. So we devised this experiment of the two blocks that move side by side, and we are going to apply the knowledge that we gathered from this experiment into the waveform display. There are two pieces of, there are two things that need to change. The first is the blocks always start on the left. When I move to another effect, so I'm no longer drawing the blocks, when I move back, they always start on the left. And I want that to happen here with the waveform display as well, because I don't want to be using resources from the machine when I am not showing the waveform display. So I don't want to be collecting samples and computing where they should be plotted. I don't want to spend those resources. You are only going to spend them if the plugin is open. So that's part one. And that's what we are doing here. No matter where we left off, the blocks start on the left, which means that we are resetting the situation of the blocks. And that's exactly what we want to do for the waveforms as well. Right now, the way that this is working is it is just going to pause, and then it's going to resume wherever it was. So I don't know if you caught this, but the bar was over here, and then when I returned, it was back there. So what we want instead is to just reset this whole view. So that's the first part. We learned how to detect whether the user interface is even open, and we learned how to detect when the user interface has been reopened so that we can clean the screen at that point. So that's piece of knowledge number one that we want to apply from the experiment into the waveform display. Part two is the movement of the blocks themselves. The block on the bottom is purely based on the time, and the block on the top is pretending to read samples, but it's also based on the time. So we'll try to apply this concept here as well and see what that looks like. And I'm going to apply these two ideas. So the idea of detecting whether the user interface is closed and the idea of syncing. We are going to do these two things in this order because the first one is supposed to be simpler. I know I keep saying that something is going to be simple and it turns out to be super more complicated than I expected, but hopefully this time I am right. So let's get into the code, and the part of the blocks is here. The part of the code that is doing the blocks moving across the screen is here. So let's see what we need to detect that the user interface has been closed so that the audio thread doesn't have to keep pushing samples into the circular buffer, because the UI thread is not reading those samples. So we'll have to detect whether we are even running, and we'll have to also detect that we started to run again. And when I say we, I mean the UI thread, this thing here. So let's see what we have for that, because the two concepts are actually kind of intertwined. The concept of detecting that the user interface is not showing is kind of intertwined with the implementation of the blocks moving. So I'll have to tease these apart and bring them into the library. The first part that I notice here that has to do with that is actually pretty simple. It's this block. It's just looking at the clock when the user interface thread is running. And we do have a place to put this already, because in the library, for other reasons, we already have this callback. So anytime that you are using the library and you are in the GFX block, you must call this function for things to be initialized properly. So we already have a hook. All we have to do is go into that hook, and then as it stands, this hook has the purpose of initializing a bunch of variables, which means that it only runs once. That's what this line is doing. It's a guard preventing the block from running multiple times. But in this case, we do have some code. We have a piece of code that we want to run multiple times. Let's get this from here. And naturally, in the library, we are namespacing everything with underscores. Also, I think it makes sense for me to namespace this with GFX, because it is the time of the execution of the GFX block. So I think it makes sense for me to have this in the name of the variables. And then there is this thing here, which is the previous time is equal to undefined, and then I initialize it. I think that we can get away with just putting this line here, because this is already a guard that says that this is only going to run once. Yeah, I think it makes sense. So I don't need to guard like this. I can just say this over here. And then there is also a line at the bottom that updates the previous time, and we'll need that as well. And I think it goes here. And naturally, I will need to rename a bunch of things here as well. Let's see if that makes sense. Every time that we are going into the GFX block, we are calling this too late. Interesting. I saw like the stream glitching for a moment. Let me know in the chat if the stream glitched and if you lost some part of the train of thought here, and I can recap, because the stream just, it looked for me like it was loading. So I don't know, maybe it was dropping the connection for a moment. But we should be back. Right, so this is already an issue, because by this point, if the current time is, well, if the previous time is undefined, then this will be a huge number. Oh, Tail is here. Hello. It's great to have you here. And thanks for letting me know you had to refresh the YouTube page. That's kind of awkward, isn't it? But we are back. And overall, what I'm doing is just transferring things that we did yesterday into the library and trying to make sense of the interfaces I will want to have for users of the library to actually use these features. So for instance, one thing that I want to have in the library is this notion of how much time has elapsed since the previous time we ran the GFX block, which is useful for any kind of animations and drawing, anything that is time-based. And most things related to visualization will be time-based. And Bo is here as well. Hello. How are you doing, Bo? Are you feeling better today? I hope that you are. Right, so we saw this problem before. The time previous has not been initialized yet. So I guess what I will have to do is to check. Maybe I can just do all this updating below. Because if I just do it below, then this will have run already. Yeah, let's consider that. Maybe it will work. Oh, great to hear, Bo. Great to hear that you're feeling better now. I am not 100%, I should say. I just got the booster vaccine today, so I have sort of a headache. I was even considering turning off the cameras so I didn't have to put this huge lights in front of me because of the headache. But I thought it would be nicer if the camera was on, so I'll stand the headache for 1 hour. Okay, so the way that I'm doing this now is I am setting for a single time. I'm setting the previous to be the current time precise, and then this is going to run every time, so it will be fine. And then this will run, it will set the current time. This is the part that we are actually interested in. And this is actually the variable that I think most people are going to be interested in looking at, because this is the difference in time between the current and the previous. In most cases, I don't think we are interested in what time is it. We are not interested in the time. We are interested in how much time has passed since the last time we have been called, we being the user interface thread. And then I reset this for next time. And I think that this works. So I'm thinking how I want to go about testing if this works or not. It's really hard to write an automated test for this because it depends on time and because we need something happening on the GFX block. I guess the only way to test this is just to open a plugin, look at the variable, see if its value makes sense. So that's what I will do. I can remove the waveform display and re-add the waveform display. And then look at underscore GFX underscore, underscore GFX, where is the letter G? Time elapsed. It is a small number and it kind of makes sense. So I'll just believe that that is working. Yeah, it's pretty straightforward. It should be working. Then that does it for computing how much time has passed, which will be something that we are interested in when we are computing how much the little square has to move. So we will want to use the variable that we have just created. We will want to use this variable soon when we get to actually scrolling things, but we are not there yet because we also need the notion of the UI thread is not even open, so let's not push things into the circular buffer, which is this part, the GFX is running situation. And here we have sort of an optimization, which is very nice actually. It makes things faster. The optimization is we check for the time to see if the GFX block has run recently. If it has not run in the past half a second, we say that it's not running, and then we stop collecting samples for it to display. But we are doing that in the block so that we don't have to check on every sample. And this is kind of an optimization. It's kind of a smart move because the block is called much less often. But I don't really see a good way of fitting this into the library. Currently, we have no equivalent of this for the block. We could have, but we don't have. And I wonder if it matters too much if we just do it like this. So right now, our little plugin moving the square across the screen is taking 0 CPU. It's not taking any CPU whatsoever. But now, if I don't use this optimization and I check the time on every sample, does it matter? It's probably going to be, by definition, it's like a couple hundred times or a couple thousand times slower, right? Because we're running this time precise much more often now. But is it something that really matters? Maybe. It may have a cumulative effect. No, not that. But I'm interested in knowing if this is going to increase that number. It's going to make the CPU a bit higher, the CPU use a bit higher. It doesn't seem to do that. And it makes for a much less awkward interface. Because if I were to use this block optimization, then I guess the only way I can think of doing that is to have a function that is similar to this, except that it will be called function_block, and then you will have to tell everyone using the library that you must call this function. You must declare a block. And that you must call this function, and that's it, actually. That's all. And then over here, we'll do this. But I don't know. It's more work for the user to have to do this. What do you all think? You all in the chat, Tail, Bo, and anyone else who is watching this, cast your votes. Do you think that I should do it like this? So it requires a bit more work on the user of the library's part, but it will be slightly faster? Or do you think that it's fine for me to just put this in the sample block and go ahead? For what it's worth, time precise seems to be almost twice as slow as calculating the sign of something. Yeah, for sure, looking at the time, especially with the kind of precision that we are getting, is slow. But hang in there. Hang in there. In the GFX block, we are interested in the minutiae of the time. We are interested in the microseconds of the time because we want to scroll an animation smoothly and everything. But in the sample block, or in other situations where we are just trying to detect if the GFX block has run recently, we don't need the precise version of time. We could get away with just time. So if the time minus the current is less than 1, this version of time gives me time in the precision of this is in terms of seconds, while the precision of time precise is in terms of microseconds. So this is much less precise, but it should be good enough because the user interface has been closed for more than 1 second. Yeah, sure. And regular time seems to be just as slow as sine. So there you have it. Interesting. Thanks for doing that experiment, Tail. And I think that I'm willing to just take this slowness. It's fine. It's computing a sine. It's like If you are automating a cutoff of a filter, you're computing sines, I guess 3 or 4 of them. No, I guess just one. But you're still computing sines on the audio thread, and it's probably okay. It should be okay. I will go with this version until someone tells me otherwise. I will not do this. Yeah, we could optimize later on. The problem with optimizing later on is that this library is going to be hugely successful. There will be thousands of developers using it, and then this will be a breaking change. Or whatever. So now we have captured the notion of the time passing. It's this. All we gotta do is create a function to be used on the sample block. And I don't know exactly where to put this function, but I think it should be near the GFX stuff. So not in the design system. Oh, interesting. I will reorganize things here a bit real quick, because this is actually a section about the design system, and now there is more than the design system here. There's things like printing and rounded rectangles. No, I'll do this organization later, whatever. I'll just write a function that I will call GFX is running, and though it has GFX in the name, it's supposed to be called from the sample block. And that's what the function does. If the current time, the difference between the current time and how much time has elapsed. No, hang on. No, I should not be looking at the time that has elapsed. I should be looking at the current time. That's what I'm doing here, time current. So if the current time, if the time that has passed between now and the last time that the GFX block ran, if that difference is greater than or equal to 1 second, it means that the GFX block is not running, or that it is running. Oh, hang on. I got it backwards, didn't I? It should be less than 1 second. The GFX block is running if the current time, the difference between the current time and the current time, crud. The GFX block is running if the difference between the current time and the last time that the GFX block ran is less than a second. In other words, the GFX block has run in the last second. And then this value is, if the GFX block is not running, then this value is going to keep increasing because time is still passing, but this value is going to be stuck. So this number is going to start to become very large, and then a large number is not less than 1. Okay, I finally think I have a grasp on this. I think I got it right. So now we can, in the waveform display, come to the sample block and check. If the GFX block is running, do that. And this is the kind of code that I want people to be able to write. Without ceremony, just ask, is the GFX block running? And we have swept all the weirdness into this function. Great. Do I want to keep these changes? No. Do I want to keep these changes? Yes. Do I want to keep these changes? Yes. How do I test that this thing is working? Here's an idea. I will come here to the waveform display real quick, and I will do a little trick. If the GFX block is running, then sample 0, then sample 0 will be 1 to say that it is running. Otherwise, sample 0 will be 0 to say that it's not running. There is a simpler way of writing this. Let me refactor this real quick. In practice, you probably don't want to be calling this function multiple times, but whatever. So now this is doing the thing that I wrote before. It's just saying output the value of this into sample 0. Why am I doing it this way? I was going to say that I want to see, even with the fetch closed, what's going on, but I'm not really sure that this was necessary. I could just have set a debug variable and looked at it in the debugger, but whatever. Let's just see if this works. Now, I don't want to have my voice going through no more, and I do want to have the waveform. And now here we are. The UI thread is running, so this is a 1. And then when I close it, it should have become a 0, and it does become a 0. Great. And if I reopen it, it should go back to 1. Okay, we proved that the thing works, but writing a unit test for this, again, it has to do with timing and everything. I think it's complicated. I will not write a test for this, a unit test for this. So what's next? We already did this part. Well, we also need to do this part. This is the GFX block was not running, but now it is again. It just started running. How can we detect that? Well, I think we can also have this over here in this part of the initialization process. Okay, I will think about that in a second, but first let's read what Dale learned. Time precise seems to be query performance counter on Windows, which might take a long time every now and then. And then he tried to paste a link, but YouTube is annoying and doesn't let you all paste links. I'm not sure if I can grant you the privileges to do that. Manage moderators, you say. Approved users. Interesting. I'm looking here at the interface for this, and the block links is disabled. So I guess I can just approve a user, tail tn, no matching users found. I guess I would need to add your channel URL. Yeah, I don't know your channel URL, so I don't know how to add you as an approved user, so I don't know how to how to let you send links, but you know how to get to me otherwise with email and whatnot. And German Churling is asking, hi, are you streaming every day? Yes, my tentative schedule is that I stream every weekday at 6:30 UTC plus 1, so I guess 7:30 UTC. That's my tentative schedule. I try to stream every weekday for about an hour. In practice, sometimes I have other things that I need to attend to. Sometimes I'm just too tired. So I don't stream every day religiously, but that's the tentative schedule. And yeah, I can Google for query performance counter spikes, but I think I will take it. Seems like hard work there. Yeah, I am hard at work. I'm trying to get things off the ground here on the channel and on the library and everything, and that's hard work. But yeah, performance spikes, I think I will take them. I don't think I should worry about them too much, because the other way of doing this is with the whole counter situation that we discussed yesterday. It's possible to do this without looking at the time. Yeah, in fact, it's possible, I think, even to do the smooth scrolling without looking at the time, because the timing of the GFX block is variable. Sometimes frames are dropped and everything, but the timing of the sample block is relatively more stable, at least in comparison to the GFX block. So the GFX block is supposed to be called 60 times a second, but sometimes it's called less often, and even then the timing of the calls are not super precise. But the sample block is running 48,000 times a second, and if a sample is dropped, we hear that. So Reaper doesn't let that happen unless it runs out of resources, or at least it tries to prevent dropping samples as much as possible. So we could rely on the timing of the sample block and take that as the time. Instead of looking at the clock. But I don't think I want to do that. We played around with counters yesterday and it was not good. Yeah, and in fact, the time precise documentation in JSFX, I think, mentions that it has to do, or that it can be used for performance measurements. So using it for drawing may not be ideal, but I think it is what we are going to do. And if there is a performance spike every now and then the waveform display is going to glitch, I think it's fine. I think I will take it. And what is even a long time? Is it like half a second, or is it a minute? Because if it is like half a second, then it's probably going to be fine. The screen is going to glitch a little. If it is like a minute, then that would of course be terrible. But I think I would just ignore all these issues. It's good that I know about these issues, so thanks for sharing and for setting me straight. So it's great to know about these issues. I think I'll just ignore them. Same as this, right? Using the time function in the sample block. Not ideal, but I think it will do. I think it will be fine. Until I'm proven wrong. Right, so let's move on. Let's see how we can detect that the GFX block has been just initialized. How do we do that? Interesting. I think there's a way to do this that is kind of cute. Before I set the time current, I can just call this. And when I call it, it's going to tell me if the GFX block is running. And I can do that in the GFX block itself as long as I'm doing it before this line. So if I want to call this function before this line, I will need to move things up. Because I can only, in JSFX, I can only call functions that have been defined above. And then over here, I will have a variable that is called maybe should reset or just opened. I'll just call it reset. Yeah, I think I'll do that. So it should reset if it was not running. The GFX block should reset. If it wasn't running, and then the next time this goes around, it will have updated the current time, so this will be different. So I think that this works. Let's see. What I'm going to do is come here to the GFX block and write I think that I could do it here in the GFX block of the plugin. I could reset stuff. But I could also just do it here on the waveform display itself. And that's what I'm about to do. Let's find the place in the waveform display where I am drawing stuff, which is here. And I will write some code to reset things. So right after I read all the variables, I will say if I should reset, then I will have to do a bunch of things to actually reset. I will have to erase what's on the screen. So in order to be able to erase what is on the screen, I will have to have this already run. So probably I want to have this above. Like this. But then we have to review these variables and see if they are going to be reset themselves. So what is the image duration in samples? I think that this is just something that we set and then we don't change. The image width is something we set and we don't change. The image height is something that we set and don't change. So all of these are variables that are not dependent on what's going on in the waveform. So this should be good. So now we can reset the image itself. And how do we do that? Well, we can just draw one of these mole edge rects. And we want to erase the whole image. So we do that by going from 0, 0 down to image width, image height. And then we erase. So we are now multiplying by R, red is 0, G, green is 0, B, blue is 0, A, alpha is 0. So we are erasing. We erased the image, but we also need to reset some of these variables. This is the circular buffer. We don't reset that. The samples, we don't reset. The write index, we don't reset, but we do reset the read index. We set the read index to be the write index again. So we are snapping the read index back into the write index because the read index it was stopped. It wasn't running. So the read index just sat there. And to be honest, the write index just sat there as well because we are now detecting that the GFX block is not running. So we are not pushing into the circular buffer and the write index is just sitting there. But still, it makes sense to snap it back. Then the image is just the image, that's fine. The image width and height is okay. The duration hasn't changed. The column samples, what is that? I think I know what it is. Yeah, it's the circular counter that says how many samples have already been collected into the column that we are considering right now. So we need to reset this to 0. And I think that that's how we reset stuff when we have just created the waveform display to initialize things. Yeah, see, column samples is equal to 0. And the maximum and the minimum also has to reset. So maybe I should have this stuff in a separate function because it will be called both from here as well as from there. but the initialization is not going to be exactly the same. For instance, this I don't want to change. I could also have some notion of resetting the circular buffer, but I will not do that. Yeah, I will not do that. I'll just copy and paste some code if necessary. So how do I reset this image column samples? I reset it to 0. Then this maximum and minimum will look like this. And what else do we have going on? The previous top and bottom I will have to reset as well. And this time it's not going to be height divided by 2, it's going to be image height divided by 2. Or image height midpoint. This is important because height here is the height of the temporary image in which we draw to, and height here in the draw function is the height that we are plotting into, and these numbers can be different. We could be drawing into a big temporary buffer off screen, but then plot it very small so that you are able to zoom if you want that. Oh, that's another thing that we need to implement. Is it on the to-do list? I forget. Zoom, it is on the to-do list. Okay. What else would I want to reset? The right index of the image is something that we want to reset, and I will just reset it to the left. And then samples per column does not change, and image height midpoint doesn't change. Okay, so I think that we wrote all the resets that we needed. If we did this right, then the behavior is going to change. Right now, the behavior is that I am drawing the waveform here, and when I go to another plugin, so check this out. I am drawing the waveform here, and I will have something very distinctive, like a click. And now I moved somewhere else, and I will let some time pass. But what's going to happen when I come back, because I have not updated the instance here yet. So we wrote all this code, but the code is not running yet. When I come back, you will still see that click, and the cursor will be all the way to the right, and it will come back to the left. See, just happened, and the click is there. But now I'm going to reload the plugin into the track, and it will behave differently. Okay, it's still drawing into this onto the screen just the same. And now what I expect to happen is when I reload, it should start on the left, the same way it started when I just loaded the plugin. And there you go, ladies and gents, we did it. Okay, this seems right. This seems okay. And this seems to be working as well. I was thinking of writing some kind of test for GFX reset. I think I will, but I think that this is already testing stuff, right? I think that we are not resetting all the time, so this should be working. But still, I'm going to write a test for this. So if I should be resetting, then that. Again, this is a trick that I use to see if a line has been executed. So reset is equal to 1 because we have just reset, we have just loaded the plugin. Now I'm going to go out, and reset is still 1, all going well, and then reset should be 2 now, and it is. Okay. Besides the waveform display resetting, I have also proved that the thing is working that way. Okay, anything else that I may be missing? Let's review. On the experiment, we had this notion of time. We had a notion of if the GFX block is running, which we use on the sample block to prevent the circular buffer from advancing. In fact, here is something. When I am, well, I was going to say that when I am off the plugin, we should see the circular buffer not updating anymore. But the fact is that the circular buffer is updating, but it's its own data structure. It's not over here. So I'll just trust that it's doing what it's supposed to. So this is saving resources when the plugin is not running or when the user interface is not open. And I was hoping that would make the CPU use go down. Unfortunately, it did not. It still consumes 0.1% CPU, but I'll trust that you have 0.1% CPU to run my plugins. Then over here, we have this whole thing we have transferred. This we have transferred as well. This notion of, okay, we need to reset. And we did all this resetting. So all of that is fine. So the only thing left for us to do is this part, where we compute how many samples we should collect. So the most important line of code in this block is this one. We are pasting the read head into the circular buffer. Okay, so let's recap. There is this circular buffer that is used to communicate between the audio and the UI thread. The audio thread is pushing into the circular buffer. The UI thread is reading from the circular buffer. And as it exists on the waveform display, this is consuming as many samples as the audio thread has pushed. But now with this line that we are about to introduce, we are going to pace. We are going to say, okay, I want 1,000 samples. If you have 1,000 samples, give me. If you have less than 1,000 samples, okay, I'll make do with 800 samples. But if you have 1,500 samples, I don't care. I want 1,000 samples. If I read 1,000 samples, I am good, I am done, I'm going to draw, and I'm going to wait for next time, and I will get those other 500 samples that you have hanging in there. So that's the intent. And this implementation is kind of wacky, and the real implementation will have to be a bit more clever, because it will have to take into account the fact that the relationship between samples and pixels on the screen is not one-to-one. So let's get to here. This is the corresponding line to this one. So this is just the read index into the circular buffer is catching up to the write index into the circular buffer. So far, so good. So we need to introduce this notion here of how many samples I have already read from the circular buffer. Let's start by doing just this counter because it's the easiest part. So I'll need a local variable that will occur right after, I think, the midpoint. And I will have this variable be called samples read. It will start at 0, and every time we go around the loop, we increment 1. That's the easy part. Next, I have to check in the while loop. So this is the check of I'm not trying to read samples that have not been pushed yet. So that check remains. But now we will add a check that is samples read needs to be less than samples to read. I don't know, I'm making this up. So now we need to compute this thing. Hang on, let me think for a moment if I want this to be less than or equal to. Doesn't really matter all that much, it's just one sample worth of difference, but yeah, I think it starts at 0, so I want this to be less than. Okay, so let's create this variable here on the local block. And let's define this variable. It's just a simple formula that we have to write. And I try to always reason about this on the stream, but I realized that I'm so bad at thinking on my feet about this that I actually drew some diagrams before. And hopefully we'll get this right. So first, let's think about, I'm just going to reason with you again what I was thinking about 10 minutes before the stream. So first of all, there is this notion of how much time has elapsed. We want to take that into account when computing this. So if more time has elapsed, we want to read more samples. If less time has elapsed, we want to read fewer samples. Well, we now have the notion of how much time has passed. It is called _gfx dot time elapsed. This is that's the how much time has elapsed. Now we want to convert from this time that has elapsed, which is measured in seconds, we want to convert that into columns. Columns are pixels on the x-axis on the screen. So we want to convert that into columns. How do we do that? Well, we have the width of the image that we are drawing to. That's the amount of columns. That's how many columns we'll have. We'll have this many columns. So you take that and you divide by how long it should take for us to draw all of this. And I want that in seconds or milliseconds. I'm not even sure. And you multiply by the time that has elapsed. Let's reason about the units of measurement here. This is given to me in seconds. Let me double check. I think it's given to me in seconds. It's given to me in seconds. So I want to have this in milliseconds because that's what I had here. So just divide by 1,000. You know what? Yeah, I'm going to do this now, but I will have to revisit this later because I think I will want to have, it's kind of silly, but maybe I will want to have a function to convert between seconds and milliseconds because I always have to think about, do I want to divide or do I want to multiply? So I will have a seconds extract seconds to milliseconds converter. So do I want to multiply or do I want to divide? 1 second is 1,000 milliseconds, so I want to multiply. See, I just got it wrong. So this is in seconds. This will be in milliseconds, and then these two units of measurement for time match. Great. Now let's go over this formula again to see if I'll put parentheses here, though it's not strictly necessary because the precedence of the operators don't change with the parentheses. I just want to say that this is unit conversion. So it's for us humans reading the code. Right, let's go over this again. And check if it makes sense. So I want to go over the whole width of the screen in this amount of time. So this division gives me how many columns per time. Then I multiply by time. So now I just have a notion of how many columns. So that's how many columns I will want to read, but we are not done yet, because this is giving in samples, not in columns. So we still have to convert from columns into samples. But that's relatively easy to do because we do have a variable called samples per column. So if we just multiply by that, we have something that is given in columns, and we multiply by something given in samples per column. So now we have the column here when the column there cancel out. Now I have something in terms of samples. It all checks out. So I think that this is the formula that we need, and that's the formula that I was trying to make sense of, but I haven't tested. So we'll see if I got this right. And if I did, the result will be that the waveform display will look almost exactly the same for you all watching the stream, but it will look a bit different to me. It will not be as glitchy. It will not jitter as much. Let's give this a try. Awesome, it's drawing. Just the fact that it's drawing means that the formula is not so wrong, is it? I mean, for all I care, it could be like drawing to the left, it could be backwards, it could be green. But it's still drawing, it's still behaving the same. Okay, that's good news. Now, I will commit what I have and I will change the display. Currently, it's in this mode that is going from left to right, but I want it to be in the mode where it scrolls because I think that it will make the jitter more evident, or the lack of jitter more evident. Though I must admit that I still see some jitter. I don't know if you all see it, but okay, let's commit and play around with this. So I have the waveform, the X, Y, width and height. I think I will do it like this. Then do I want a square root? Actually, no, it makes everything bigger. Do I want to erase on wrap? That's only relevant when you're not scrolling. Oh, do I want to scroll? True. Do I want to erase on wrap? That's only relevant when we are not scrolling, but we are this time. What is the color of the fill? That. What is the color of the stroke? That. And what is the color of what is the cursor like? I can just put this to 0, but actually I was thinking that the implementation that we currently have is silly. Because it looks like this, it still draws the cursor even if we are in the scrolling waveform mode. So I don't want that. I will check for something else. So I will check that the cursor width is larger, but I will also check if I am not scrolling. So I think it's not scroll, and the cursor width is greater than 0. And that should do it. So now I can pass a bigger width here and I can pass a different color and whatnot, and it will just not display anything. Just like that. And there you have it. Now, is this perfect? No, it still jitters a little bit. Am I happy? No, I freaking wanted this to be more smooth. Is there anything else that we could do? Maybe. I feel like I'm chasing Moby Dick here. I think that there is one more thing, just one last thing that we could try to do. In fact, I think that maybe the jitter is worse now. Well, at least we did other things, right? When we have this going on, then we'll come back, it will start from scratch. So that's good. We made progress. But still, I'm not completely happy. And it seems to be jittering. It seems to be like jerking just ever so slightly. It seems to be doing that periodically, which is it's surprising. So I want to play around with some things. First, the refresh rate. If it's at 30 frames per second, does it look better? Well, kinda, but still it's jumping. In fact, I don't see as much difference as I thought I would between the two frame rates. Did I remember to save the file? I did. Oh, but I saved the file of the experiment. Haha, there you go. There you go. So, okay, I can still tell 60 frames from 30 frames a second. Yeah, and the jerking is still there. I can still see it kind of jumping. And if anything, it's even worse now. So no, different refresh rate does not help the case. Okay, now for the next idea that may help. The idea goes like this. The read head is snapping to the write head. And when we just load the thing, whether it's the first time you load the plugin or because you went to some other plugin and came back, the read head is snapping to the write head, which means that if the audio thread is writing faster than the GFX block is reading, then it's fine because there will be more samples for it to consume. And this should always be the case. It should always be the case that the audio thread is running faster than the GFX block, so it should never be starving for samples. The GFX block should never run into this line. It should never try to read a sample because of the, or should never try to stop reading a sample, not try. It should rewind, I'll say this again. The GFX block should never stop reading samples because the audio thread didn't have the time to push the samples there. This line here, the highlighted line, is a safety guard. It should never actually be needed. But if it is needed, then it means that the GFX block is starving for samples. It wanted to read more samples and the samples were not there. So the read head is too close to the write head. So the idea would be, what if we just leave a bit of space between the read and the write head from the get-go so that it never starves? That's an idea. Just offset the read head from the write head. It's not too complex of an idea too. It's relatively feasible. But first I want to check my theory that this line is not necessary. If I am right, I can remove the line and the behavior is going to look exactly the same. And it seems like I am right. The behavior seems to be exactly the same. This is not changing much. So maybe we didn't even need, maybe we shouldn't have that, but I think we will. I think we will have that. Now I will move this around so that the I think I am able to make happen what I was thinking about. So I'm moving this around so that my computer is straining more because I'm moving windows around, so the CPU has more stuff to do, the GPU has more stuff to do. And I think that I can start to see some waveforms that used to be like solid blocks. When I move the window around, it seems like it is maybe more jittery, which could mean that this condition was actually happening. No, if that condition was happening, that would not be the result. The result would be it would start reading stuff from the past, so it would start reading stuff from here, from the left, which is not happening at all. Yeah, samples on the left would start reappearing on the right. Okay, I think this does it. The idea of offsetting the read head is not going to help much, but still I'm going to implement it just because it is so simple to implement. What do we need to implement this? We need to first creating this. Where is my read head? It's here. Okay. So I will just initialize this to, instead of 0, because the right index, not this one, this is the right index into the image, but the right index into the circular buffer also starts at 0. So to offset this, I can just make it a number that is based on this size. So this is the size of the circular buffer, and I'm just hacking this together, so I'll not try to make things elegant by extracting variables and whatnot. I'll just tack this on here. So this is the size of the circular buffer. And then I will wrap minimum. Let's say that we'll give 200 samples of give between the read and the write index. And that's how you use wrap minimum, right? You take the value, the minimum and the maximum. Yeah, I think that does it. So effectively, this is just a way of computing the size minus 200. So I might as well, right? No need to use the library function for that. I'll just take the size and subtract 200. So this way I am putting the read index 200 samples before the write index, because now it's way to the right into the circular buffer. Okay, there you go. This is it. Then when I reset, I would need to sort of do the same computation, but I will not worry about this now, because I can just not close the plugin and reopen, and we'll see if on the first load it looks any better. And I don't think it does. I don't think that the UI thread is starving for samples. I think it's just the case that the UI thread is maybe not called as often as it should. I think I'm going to rule this as a limitation of JS effects. It doesn't call the GFX block as often as it should for the scrolling to be smooth, because really we are taking care of all the concurrency issues, everything we could think about. So unless you all can think of something that I'm missing, I think that this is about as good as you can get in JS effects. Now that said, when I look at something like this, it puts my animations to shame. So I guess there's still more that I could be doing. I just don't know how to. Psyche, if you're watching this, help me out. I think that does it. I don't know what else to do to make this smoother. So with that, let's take small tasks, low-hanging fruits that we can get out of the way real quick. Let's see what we have here. We have zoom. Zoom is easy. We already have a slider for it even here. So we'll just add another parameter. So we have X, Y, width, and height. Let's have zoom, and maybe I'll call this scale. And we implement this before when we were only scaling on the vertical axis. It could be nice to be able to scale on the horizontal axis as well. Yeah, I will leave this here. Scale on horizontal axis, because then you would be able to like scroll your view of the screen. Of course, not by much, because you're limited to how much we are drawing to on the off-canvas image, but still, it could be nice to be able to scroll that if necessary. But it's a good to have. The main thing for me is being able to scale vertically. So just call this scale for the time being. And all the action is going to happen over here when we are bleeding the images. Let's start with this version, because this is the easier version where we just bleed once. And that version is the scrolling one, the non-scrolling one, actually. So do I want to take the square root? No. Do I want to scroll? No. Do I want to clean on wrap? No. Then I think we are back to the non-scrolling version, right? Oh, but I added one parameter, the scale. So XY width, height, and scale. And let's do scale of 50, which is half. Okay, so we are back into this form, and let's think about this split. What do I need to make this split smaller? You know what? As you can hear, family just arrived, and this is going to be slightly more complicated than I was expecting, because I will have to compute all these coordinates to make things work. And in fact, I think that some of these coordinates we just fudged. We are currently drawing the waveform smack on the top left of the window, so that we wouldn't have to take in account X and Y in all these splits and in this as well. So we are putting X and Y here and there, but I'm not 100% sure that this is actually working. And when we are scaling, we will have to take care of that as well. So I guess I'm just going to revert what I have so that the thing is at least in a functional state. And then we will wrap up. And tomorrow I will be on IDQD Sound. I will be with Aria, and we'll be talking about audio production. So I will resume this work here on Monday over here on my channel. I don't think that there was anything worth committing there, right? So with that, thank you, German Tail Bow, for being active on the chat. Thank you everyone else who was not active on the chat but is watching nonetheless. And yeah, I see you tomorrow over at IDQD Sound. Have a good one. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.